In the previous video, we had a look at slope denoted by the letter m. Here we have the general formula y equals mx plus c, and let us try and solve for m to get a general formula for the value of slope m. So what I can do is I can swap the two sides, or rather flip the whole equation and write it as mx plus c equals y, right? So I just flip the whole equation, and now I can subtract c from both the sides. I get mx, now plus c minus c just cancel out, so I'm left with only mx on this side, and on this side I have y minus c. Now I can divide both the sides by x. Here x and x cancel out, and I'm left only with m on this side and y minus c upon x on the other side. So this is the general formula for the value of m, which says that m equals y minus c upon x. Let me write that here. M equals y minus c upon x. Now let us take an equation like so: y equals mx minus 1. Here the y-intercept is known, which is minus 1, but the value of slope or the value of m is unknown. What is known is that 2 comma 3 is a solution of this equation. Now can we really use all this information to find the value of m? Well, it turns out yes, we can take this information, plug it into this general form and find the value of m. So let's do that. M equals, now what is y? Well, 2 comma 3 is the solution, which means 2 is the value of x for a particular point, and 3 is the value of y, right? So I plug that in. Instead of writing y, I write 3 minus c. What is c? C is minus 1. So minus 1 upon x, which is 2, right? Solving this further, I get m equals 3 minus 1 is plus 1 upon 2, and 3 plus 1 is 4 upon 2. Therefore m equals 2. So the value of slope is 2. Perfect. Now let us verify this graphically by actually plotting it on a graph. So here I have the graph and I have plotted the linear equation on the graph. Here you can see that 2 comma 3 is indeed a solution of this linear equation because it really lies on the line, and here minus 1 is indeed the y-intercept, because this is the point minus 1 where the graph intercepts the y-axis. Now what I really need to confirm is the value of m2 through the graph also. So what I can do is I can look at how much the value of y changes or y increases as I go 1 unit along the x-axis. So let's go from here 1 unit along the x-axis. Now forget these the scaling of the actual x-axis. Let us just stick to the boxes as a single unit. So let us take this as 1 unit. So that is 1 unit. So let's say x increases by 1 unit. It goes from here to here. That's 1 unit. What is the increase in y? Well, the increase in y is from this to this, which is this much. And so y increases by 2 units. If you see, it has increased by 2 such boxes. So 2 units. So for 1 unit increase in x, I get an increase of 2 units in my y value. So essentially my slope is equal to 2, because for every incremental change of 1 unit in x, I get a change of 2 units in my y value. Even if you see it along the at any other point, let's say I go from here to here 1 unit, the y value increases by 2 units, right? So the rate of change of my y is equal to 2, right? For every 1 unit, my y increases by 2 units. So the rate of increase of y is really 2. So that means my slope is 2, and so m is equal to 2, which really confirms my